Welcome to this video on quadratic inequalities. Let's go. So, with this type of question, as in the past, you've looked at quadratic equations, you've looked at quadratic graphs, and a bit about inequalities. So now we're just putting these two together. So as you can see from the diagram I have, the graph, if we have a quadratic equation and we express that as a graph, okay, if that quadratic equation is less than 0, then it will be just a red mark. It'll be that region there, which I've shaded in. That would be the values you want. And if the quadratic equation, if it's greater than 0, then where I've drawn the shaded region there, that is where you want your values to be. Okay, so if we go through an example now, here, we have this quadratic equation here with x squared minus 4x minus 21, and that is less than 0. We need to work out the values of x which satisfies this equation. So first things first you want to do is you want to factorize it, you want to solve for x. So if we do that here, then, well, we know that the two numbers which can sum to make minus 4 and multiply to make minus 21, that would be a minus 7 and a 3. So it would be x minus 7, x plus 3, and that is less than 0. So therefore we get x is equal to 7, and we get x is equal to minus 3, okay? So now if we're to draw this on a graph, okay, if I draw the graph here, we do it like this. And then if we're to draw this graph out, well, we know that a quadratic graph, if it's a positive x squared, then it's going to be in that U shape, okay? And we're going to have a point, let's say here, another point, let's say here, okay? So this represents the minus 3, and this represents the 7. And then if we draw that in a U shape, something like this, doesn't be too accurate. We know that we want the points where it is less than 0. So less than 0 would be these values here. So what would that be then? Well, if it's those values, then we can clearly know that the answer would be minus 3, which is less than x, which is less than 7, okay? We want all of those values in that region there. So it has to be all the values in between minus 3 and 7, okay? So with this question, we have 6 over x is greater than 2. And on first glance, it looks like you can just multiply both sides by x, okay? So you get 6 is greater than 2x, and then you get 3 is greater than x, and you think that you're done. But you're actually not done on this question, because x can be positive or negative. So while we can do this, this is if we're considering that x is positive, x is greater than 0, then we can do that. And if we consider that x is greater than 0, then that means that x must be between this point here. It must be between 0 and 3 when x is greater than 0, because that's when x can be positive. However, x can be negative. What do we do if x is negative? Because x can also be negative, okay? So if we think about if x is negative, well, when a inequality is negative, when you're dividing by a negative number, it flips the fraction. So actually, if we consider that x is negative, then we would get 6 over x is less than 2, which would mean that 6 is less than 2x, which would also give us that 3 is less than x, okay? So now we get this, so we get this solution as well. However, that doesn't make any sense because, well, if x is supposed to be less than 0, then if 3 is less than x, well, 3 is a positive number, it's not less than 0, therefore it's not valid, it's not a solution. Therefore, in this question, our answer would just be 0, which is less than x, which is less than 3. However, instead of doing this every single time, because you may get more difficult ones where it may not work out like this, there's an easier way to solve it. So I'll go through that now. So the way you can solve this and to get rid of all those problems is just to multiply both sides by the denominator twice. So in this case, multiply both sides by x squared. If you do that, it gets rid of all of the different variables, and then you can solve it like normally. So if we do that, therefore we would get 6. If we multiply both sides of x squared, we'll just be left with a 6x here, and that'll be greater than 2x squared, okay? And then we can just solve like normal. What I will do here is I'll bring that 6x to the other side. So we get a 0 on this side is greater than 2x squared minus a 6x. And now I'll just rewrite this as 2x squared minus 6x is less than 0. Okay, I've just moved it to the other side. And now we can just factorize. We factorize, we get 2x in brackets x minus 3. Okay, and that is 0. And now at this stage, if I draw my graph, I'll draw on the right side here. We draw a graph here like this. We know there are two values here. We're going to get x is equal to 0 and we're going to get x is equal to 3. So we have a root here at 0. We have a root here at positive 3. This graph is going to be positive. So if we draw the graph something like this, and we know when it's less than 0, so it's going to be these values here. Therefore, we know that our answer must be 0, which is less than x, which is less than 3. So both of these ways still give us the same answer, but this way is a lot easier because if you're dealing with more difficult examples, then just timesing everything by x squared will make it a lot easier. Okay? Okay, so now we'll go over a few questions. The first one will be x squared minus 5x minus 14 is greater than 0. We need to look at the set of values of x. So again, just factorize. So two numbers which sum to make minus 5 and multiply to make minus 14. That will be x, that will be a minus 7, and that will be an x, and that will be a positive 2, okay? Okay, and then if we work out them out, that will be x is equal to 7, and x is equal to minus 2. Now, if we draw the graph, so we have this, and we have that. We will have a, let's say a minus 2 is here, a 7 is here. The graph will be positive, so it's in a U shape. It will go something like this. And we want the values which are greater than 0 this time. So that would just be this values and this values. So what would that be? We know that this is minus 2, and we know this is 7. So therefore, it would be, our answer would be where x is less than minus 2 and when x is greater than 7. Okay? So for this question, we need to find the set of values of x where we have 5 over x minus 3 is less than 2. So again, like one of the examples I showed earlier, again, the best way to do this is to just multiply the denominator squared, okay? So in this case, what we're going to do is we will do 5x minus 3 squared over x minus 3, and that is less than 2x minus 3 squared, okay? So whatever the denominator is, we just times that twice, okay? We pretty much square it and then times it, okay? If we work this out, we will get a 5x minus 3, okay? Because this would just cancel out with this. And that is less than 2. If we expand this out, we get a x squared minus, it'll be a 3x minus 3x, we'll get a 6x. Then minus 3 times minus 3 is a 9 here, okay? Then if we do the other side now, we get a 5x minus 15 is less than a 2x squared minus a 12x plus 18. Now, if I bring everything to the right-hand side, therefore we'll get a 0 on this side. That is less than 2x squared, stays the same. We get a minus 12x minus a 5x, so a minus 17x. And we have a positive 18 plus a 15, which is a positive 33. If I just bring everything over to the other side, it will be a 2x squared minus 17x plus 33 is greater than 0. And now we can factorize. So if we were to factorize this, we would get 2x minus 11 and x minus 3, okay? That will be greater than 0, which will give us x is equal to 11 over 2, or 5.5, and x is equal to 3. Again, if we draw a little graph, we would get we have a 3 and a 5.5, and it's in a U shape, so it would be something like this. Again, that is not the best square. Let me do that again. It will be something like this, okay? So let's say something like that, where this is 3 and this is 5.5. And we want it where it's greater than 0, so it would be these values here. And again, if you was to work that out, you would get x is less than 3, and you would get x is greater than 5.5. Okay? So we have the equation. So for this last question, we have the equation that kx squared minus 2kx plus 3 is equal to 0. And this is where k is a constant, and this equation has no real roots. So we need to prove that k satisfies the inequality 0, which is less than or equal to k, which is less than 3. So how do we solve this? Well, what do we know about this? It says that something has no real roots. So when it says something like that, in my head, I instantly think about the discriminant, okay? So what is the discriminant in this case? Well, if something has no real roots, we know that b squared minus 4ac is less than 0, okay? That's when something has no real roots. So let's work that out now. So if we have, in this question, we have kx squared minus 2kx plus 3. So we know that a in this case would be k. We know that b would be a minus 2k. And we know that c would be a 3, okay? Because this is in that form of ax squared plus bx plus c, okay? So if we know these values now, we can just use the discriminant. So b squared minus 4ac is less than 0, and hopefully that can give us some values for k. So if we do that, well, we have b squared, so that will be a minus 2k squared minus 4 times a, which is k, times c, which is 3, and that is less than 0. So that would be give us a 4k squared minus a minus 12k, and that is less than 0. So now, if we were to factorize this, we can just take out the 4k. We can also divide by 4 and then factorize, but I'll just take out the 4k, and then we get a 4k and then a k minus a 3 in the brackets is less than 0. So at this stage, if we draw our graph, okay, therefore we know that if we have 4k and k minus 3, that means that k must be equal to 0 and k must be equal to 3. So we would have points at 0 here and at 3 here. And for 4k squared minus 12k, that would be positive. So again, it would be a U shape like this, and it goes through 0 and 3. And we want less than 0 or 3, so it would be these values here, which gives us 0, which is less than k, which is less than 3. But are we done yet? No, we're not. So with this question, it says that the equation has no real roots. So what we need to do is we need to verify if when k is equal to 0 and when k is equal to 3, does it have roots at those values? Because if it does have roots, then we don't want to include it. But if it doesn't have roots, then we want to include that in our answer. So let's start with the 3, okay? If k was equal to 3 in this question, then we would end up with 3x squared minus 2 times 3x, that would be a minus 6x, plus 3 is equal to 0. So does this equation have roots? Well, if we were to just divide everything by 3, we'd get x squared minus 2x plus 1 is equal to 0. And yes, that does have roots because we would get an x minus 1 squared is equal to 0. And this clearly has a root at 1. So therefore, we know that when k is equal to 3, we do have roots. So we don't want to include when k is equal to 3 because we have roots when k is equal to 3. And in this question, we want it when it doesn't have roots. So that's why in this case, it's just less than 3, okay? Now we consider the same when k is equal to 0. If k is equal to 0, then what do we get? Well, if k is equal to 0, then we would just be left with 3, because we'd have 0x squared, 0 times x squared, minus 2 times 0 times x plus 3 is equal to 0. We'd just be left with 3 is equal to 0. That doesn't make any sense. 3 can't equal 0, therefore this is not a solution, therefore this there doesn't have roots. Therefore, when k is equal to 0, that doesn't have roots. So that's why we include, in this question, we include that equals sign, so it's less than or equal to. So actually, that is why our answer is 0, which is less than or equal to k, which is less than 3. Because when k is equal to 0, we don't have any solutions, we don't have any roots. Therefore, it is 0, which is less than or equal to k. But when k is equal to 3, we do have roots. Therefore, we don't want to include it. Therefore, it's just less than 3. And when you put that together, you get 0, which is less than or equal to k, which is less than 3. So I hope you enjoyed this video on quadratic inequalities. I hope to see you on the next.